Hey guys, welcome to another Algebra 2 video. In this one, we're going to talk about how to multiply polynomials. And that's the official title of the video, but really what I mean by that is how do you multiply things that have x's and x squareds and things like that with numbers? So a polynomial is just a thing that combines x's and numbers. So something like x plus 3 or x squared plus 5x plus 1 or things like that. What happens if you are working with structures like this, and you want to multiply them by a number, or you want to multiply them by themselves, things like that. Everybody knows how to multiply numbers, hopefully, if you're watching this video, but it gets a little bit more complicated when you start adding letters and things. Before we jump into how to actually do this, let's cover some basics on how to add things with x's and things like that, just to make sure all our ducks are in a row, and so we're all on the same page. So I'm going to give you a very, very simple example, and this may be elementary to you. Let's say you have 2x plus 3x. If you're adding things with x's, all you're really doing is just counting how many of something you have. So what I mean by that is, you could think of this. Let's say you had 2 cats, and then you had, for some crazy reason, you wanted 3 more. If you were to take 2 cats and you added 3 cats to it, how many cats do you have? Well, everybody would probably say 5 cats. It was something I want you to notice is the fact that when you add 2 cats to 3 cats, you don't get 5 cats squared. That's kind of weird. I don't even know what cat squared is. Uh, the point is, it doesn't change what you're counting. When you add things like this, you're literally just counting how many of them you have. But I cannot tell you how many times students will take something like 2x plus 3x and they will write 2x plus 3x as 5x squared. And that comes from a misunderstanding of what's actually happening here. Because when we start introducing letters and numbers, all kind of intuition about what's actually happening seems to kind of go out the window sometimes. So really what we're doing, just to be clear, is we're saying I've got 2 of these, whatever this is. It doesn't matter that it's a letter. Like I said, it could be a cat or it doesn't matter. And I've got 3 of these, same thing. So how many of these do I have? Well, it's the same thing. I'm just adding it up. All right. So if I've got, 5 x's and 6 x's and another x, how many x's do I have? Well, that's 5 plus 6 is 11. Then plus one more. That's still just one more. That's going to be what? 12 x's. This does not change what it is that I'm counting. I'm not changing what it is. I'm just telling you how many I have. Right? Okay. So point is, when you add things with x's or y's or any kind of variable, you're not going to change what the variable is because you're literally just counting them up. That's what that means. All right. Okay, that's out of the way. Let's talk about multiplication with x's. So x times x, this is a little bit different story. This is where those exponents come in, and I want to kind of talk about y just a little bit. We're not going to go too in-depth because there's really not that much to it without getting too in the weeds and theoretical and stuff. Anyway, what does it mean to multiply something times itself? Like if I said, what is 3 squared? Well, most people would say it's 3 times 3, which is 9. Think about what that's really doing. We're saying that this square means taking something times itself, right? So when you ask, or when you're given something like x times x, you're kind of running that step backwards. You're saying, I have an x times itself. That's the act of multiplying something times itself. We know what that does. That is the act of squaring something, okay? That's where that square comes from, because it's literally saying that I want to multiply x times itself. It's just kind of running it backwards, right? So just like 4 squared really means 4 times 4. We're used to thinking of it that way, like in a forward sense. What does squaring mean? Times itself. But we're not usually used to thinking about it backwards, like 4 times 4 is 4 squared. That's why x times x is x squared. It's literally something times itself. And so then when you have 3 of them, x times x times x, that's where you get x cubed. You're counting up how many multiplications you're doing. All right? And that's not to be confused with when you're adding them together, remember? Because when you add them, you're not going to change that exponent. Okay, that should be enough of the review on how to add and multiply things. Let's get into some multiplying polynomials. Let's write a very simple one. What if I were to combine some x's and numbers? Let's say I had x plus 2. The first question I want to ask is, well, why do I have to write x plus 2? Why can't I just combine those together? Because I have seen many students say, well, if you take that as a problem and I ask you to simplify it, they will say, well, that's 2x. But that's not really what's happening here. You can't add these two things together because they're completely different quantities. You don't know what x is, but 2 is a known quantity. These are very different structures. So they're not something that you can just add together. So the most we can do is just set them next to each other and say, I don't know what x is, but whatever it is, I'm going to add it to 2. So you have to leave it this way, right? If you were to say 2x, what does that mean? We already know that means that's 2 x's, all right? Now, is this and this the same? No, not at all, right? So 2x means x plus x. That's what that means. So this x plus 2 thing is not what that is. All right, I probably went too in-depth into that. But I want to drive the point home that this is a structure that can't be reduced. You can't combine that x and that 2. So then, if you want to say multiply this by something, you want to like multiply it by 3, you have to multiply this entire grouping of things. So what happens is you have to end up putting parentheses around it. And that's why we have parentheses, to say that you're going to multiply this entire thing that is x plus 2. And why? Because I couldn't crunch them any lower. I couldn't make them any closer. But you're going to multiply that entire thing by something out here. Well, if you've done this before, which you probably have, you know that this is an example of the distributive property. And the distributive property says that if you have a number out front, then you can multiply it by everything inside the parentheses, and that's the same as multiplying it by the whole thing, right? So let's do that. So this says 3 times x, that's just 3x, and then 3 times 2, 6. Easy. It's literally all there is to that. All right, let's do another one. Let's do 4 times x minus 5. All right, same thing. You're just going to take that number out front and multiply times everything inside. So 4 times x is 4x. If you're not convinced, I didn't really go over this. Why is 4 times x 4x? This is like saying 4 times something is saying I have 4 of them. Remember at the very beginning I said, if you have 4 of something, that's what that 4x is. Anyway, probably don't need to get down into that anyway. So 4 times x is 4x. 4 times negative 5 is negative 20. And that's it. You can also do this with larger groupings of things. Let's say I have 5 times something larger. Let's say, I don't know, this. It doesn't matter how many terms are inside this thing. If you've got something on the outside, you're just going to multiply it all the way through. It doesn't matter how many there are. The concept's the same. So in this case, I'm going to multiply times all 3 of them. 5x squared, that's like saying I have 5 of these. I have 5x squareds. How do I write that? Like this. And then I have 5 times 2x. And this is the first time, at least in this video, we've talked about where you have a number times a number. So this is like saying I have 2 of these, or 2x, 5 times. If I have 2x 5 times, how many of x's do I have? I have 10 total. That's 5 times 2 is 10, and the x is here. So 5 times 2 is 10, and then the x comes along for the ride. You could think of it that way. Now 5 times 3 gives me 15. All right. Very simple. Let's try one with a negative. Let's do, say, negative 2 times x squared minus 4x plus 6. All right, if you want to try this one real quick, pause it for a second and try it, and we'll do it together in a second. All right, let's multiply through with this negative 2. This gives me negative 2x squared. A negative 2 times a negative 4 gives me a positive 8. That's how you think about that. Think of this as not minus 4x, but I would think of this as a negative 4x. That's what that really is. Now, negative 2 times 6 gives me, oh, I forgot the x. Negative 2 times 6 gives me a negative 12. All right, so that's the distributive property. And to be honest, most likely, if you're watching this video, you've already seen the distributive property. So far, all of this stuff is a review. You know all this stuff. What you're probably here for, to be totally honest, is something like this. When you have groupings where you have multiple things like x plus 5, x plus 2, we call these binomials. It's a binomial because it has two things in it. All right, now if you haven't done this before, I would suggest trying this. Even if you don't know how to do it, just give it your best guess. Just what should you do intuitively? Give that a shot before you actually watch me do this. All right, so here's how this works. The distributive property is still in full swing. We're still going to do the distributive property. That doesn't change. It's just that now I have two different things to distribute. All right, so I'm going to just grab this first one. Let me actually start using some colors. This would be a good idea. Maybe even zoom in. So I'm going to take this first number, or this first thing, x, and I'm going to multiply it by everything over here. So that's x times x and x times 5. So let's do that. So x times x is x squared, and then x times 5 is 5x. All right, now I have completed the distribution of x. I've distributed x. But I still have another thing to distribute, so I'm going to look at this next number, this 2, and I'm going to distribute it just like I did before. So that is 2 times x, that's 2x, and 2 times 5, which is 10. So that's how that works. Now, if you'll notice, this thing down here that I've got as my answer has something I can combine. It has something I can simplify, right? Because you'll notice that, well, x squared and 5x, those are two different things. This is saying I have 5 of these, but I have 1 of these. So you can't really add those together, but what you can do is you can add these 5x's to these 2x's. So I have a total of, let me kind of show you, those combined together to give me 7x, right? And I still have my 10, and I still have my x squared. So whenever you do something like this, we have x plus a number or minus, and then x plus or minus a number. Whenever you do this multiplication thing, you're going to get these middle terms that will combine, all right? Okay, now, if you're coming at this, if you've already seen this before, you might have seen this as something called FOIL, and I'll kind of explain what that means. I don't use this term usually. I have nothing against it. I just like to think of it as distribution. It makes things easier. But what this means is taking the first of each grouping, so x times x, that's the first, right? And then the outside, which is the first and the last one, right? That's the outside terms, the x and the 5. And then I means inside, so we're multiplying the inside 2, that's 2 and x. And then the last, that means the last two pieces of each. So that's 2 times 5, and that gives you 10. It's a neat mnemonic device, I guess, acronym, but I feel like it's a little limiting because this concept extends to things with more than two pieces. But this, unfortunately, this term only applies to two things and two things. So that's why I don't really use it. But if you use it or you like it, feel free to use it to remember. But I just think it's just as simple to just remember. Just distribute everything in the first one or with the first term, and then distribute everything with the second term, and you're done. Okay, let's do another several. You guys try this one real quick. See if you can do this one. Let's do 6. Give that a shot real quick, and then come back and we'll do it together. Okay, here we go. So I have x times x. Maybe I should, this is only our second one. Maybe I should start with some labeling. You don't go too fast. So x times x and x times 6. So it's x squared plus 6x. I'll change my color here. Now I have 5 times x and 5 times 6. 5 times x is 5x. 5 times 6 is 30. And now I'm going to notice that I can combine these two pieces together. And that's going to give me, oh, different color. X squared is still there. 6x plus 5x is 11x. And then plus 30 still. Now, just another quick note. I noticed this a lot when we do these in class. If you aren't careful and you don't put the x squared here, you might think that this is another x here, and then you might combine them together to get 11 with the 1, get 12x, something like that. Be very careful not to do that. You will always get three pieces like this that cannot be combined anymore. That's as condensed as it's going to get, at least with things that look like this. All right, let's try another few. Tell you what, why don't I do this? Why don't I give you a few of them, and that way we're not just doing one at a time. I'll give you a few of them, and then you try these on your own. We're going to throw some negatives in here and see how you handle them. So pause the video, try these three out, see how you do, and come back and I'll do them for you. Okay, here we go. I'm going to do these without drawing the lines. If they help you, keep drawing the lines, but I'm going to skip that step. So I have x times x is x squared. X times negative 5. Remember, this is not a minus 5. It is, but it's useful to think of this as a negative 5. So x times negative 5 is negative 5x. Then the middle term, 2 times x is 2x. Then I have 2 times negative 5 is negative 10. And then to combine these, let me get a different color to show the final answer here. To combine the middle two, well, I still have x squared. This is a negative 5x plus 2x. If I have 2x minus 5x, it's the same thing. That gives me a negative 3x. And then, of course, my negative 10 comes down. All right, let's do the next one. X times x, x squared. X times negative 2, negative 2x. Negative 4 times x, that's the middle two terms. So now I'm distributing that second number, negative 4. Negative 4 times x is negative 4x. And then negative 4 times negative 2, remember a negative times a negative is a positive. That gives me a positive 8. All right. And now I'm going to look at these middle two terms and again combine them. Now, again, a lot of times people will look at this and if you're not careful, you think, oh, negative, negative makes positive. That's only when you're multiplying. We're adding these together. This is a negative 2 being made more negative by 4x. So we're combining these together. So they're going to combine in an additive way. So think of them as adding together to make something even more negative. So that's negative 6x and then plus 8. If you like rules, you can think of it this way. If the signs are the same, you add them together and keep the sign. I like to think of things more in an intuitive way, like what it actually is doing. But if you like the rule method, like I said, just add them together and keep the sign. There's no really wrong way to do that. Okay, last one, x times x, x squared. X times negative 7 is negative 7x. Negative 3 times negative 3 times x is negative 3x. And then negative 3 times negative 7 is positive 21. And just like in the last one, we're going to combine the middle two in an additive way. They're going to add together to be something more negative. So this is negative 10x plus 21. Okay, this really doesn't get much more complicated than that, at least not with things that look like this. But let's get into some other kind of examples, other things you might see. Let's try something like this. How about this one? Now, I highly, highly encourage you to pause the video and try this one first. Please don't watch me do this before trying it yourself, because I really want you to see if your intuition is correct. All right. Whenever I teach this in class, 9 times out of 10, what I see the answer is this. they'll take the x and they'll square it. And then they take the 4 and they square that and they get 16. And they say, okay, that's what I did. I distributed the 2 basically and I squared everything inside. And they get that answer. This is completely wrong. Okay, let me explain why. I want you to think about what this actually means. What is this? Oh, let me get rid of that thing. What does this square mean? We talked about it earlier. Squaring means taking whatever is being squared and multiplying it times itself. Okay, so if you take that quite literally, in this case it means this entire thing squared means it's the entire thing times itself. Well, what does that mean? It means this thing times itself, which is also this thing. So when you have x plus 4 squared, what you're really doing is x plus 4 times x plus 4. That's really what's happening. And that's very different from x squared plus 16 when you work all this out. We know how to do this. This is going to be x squared plus 4x from the outside terms, plus 4x from the inside terms, if you're using the FOIL method. And then 4 times 4 gives me 16. I combine the middle two, and I get 8x plus 16. That's the answer to 4x plus 4 squared. Okay, let's try another one. You try this one. X minus 3 squared. Same concept. Give that a shot and then come back. Okay, here we go. So, oh no, what happened to my stuff? Where did it go? Did I lose? Bear with me. Where did my page go? There it is. I don't know what just happened. That was crazy. Okay, x minus 3 squared is actually x minus 3 times x minus 3, right? So distributing the first thing, x times x is x squared, x times negative 3 is negative 3x. Distributing the second term, negative 3 times x is negative 3x, and negative 3 times negative 3 is positive 9. And then I combine the middle two. The signs are the same, so I'm really adding them and keeping the sign. Negative 6x plus 9. And that's my answer. All right, let's keep playing with this concept. Let's keep going. There's this. You can see a lot more different variations, other variations of this rather. What about something like this? Because this will show up a lot when we start graphing things like this. Actually, we actually graph things like this already in our parent functions section. But if you wanted to simplify this, what would you do? Well, some people might suggest to take this 2 and distribute it and then square it, right? But that doesn't really quite work because if you think about it, this 2, as we said before, is saying take 2 of those and multiply. So if I were to write this out the way this squared suggests, I would have 2 times x plus 3 and then again x plus 3, right? So really what's happening is I have 2 times whatever this whole thing is, right? So let's actually, what I would suggest doing is leaving the 2 alone and then multiplying all these things in here just like we did before. So that's really what I found one of the best methods. As long as you just don't distribute the 2 first, definitely don't do that. All right, so x squared plus, so x times x is x squared, x times 3 is 3x, 3 times x, 3x, and 3 times 3, 9. All right, now I'm going to combine these like I always do. So basically all I did was I said, all right, I know x plus 3 squared is x plus 3 times x plus 3. I'm going to go ahead and do that part first. Leave the 2 there. It's just hanging out. And then, remember at the very beginning of the video, we talked about how to do things like this, how to take a 2 and distribute it throughout the rest of this, no matter how many pieces there are, right? So this is just 2x squared plus 12x plus 18. And that's our final answer. Now, I am going to show you another method if you'd like to see it. Now, if you don't like this, don't worry about it. This is probably the most common way to do it. But just for completeness sake, I am going to show you a different way, just so you can see kind of how it works. If you're curious, it's good to know. So if you wanted to do the 2 first, you can. But that 2 does not distribute to all of them. See, if you distributed it this way, it would distribute to everything. And that's not really how that works. What's really happening is you can distribute the 2, but it's only going to go into this first term because that's what it's being multiplied by. So you can distribute the 2, but it's only going to go into this first piece. So that would be 2x plus 6, right? And then that times x plus 3. Okay, so you can do the 2 first, but it's, again, only going to distribute into one of those pieces. And now, let's actually multiply this all out. And so I get 2x times x, which gives me 2x squared. And I get 2x times 3, which gives me 6x. I have 6 times x, which gives me 6x. And then 6 times 3, which gives me 18. All right. And when you simplify this and you put the middle two terms together, you get the exact same thing that we got last time. So this method works just as easily. You have to be very, very careful not to distribute the 2 to everything. It's just into the first term. If you'd like to do it this way, you can. All right. Now, before we finish this video up, let's talk about a couple of other kind of variations you might see in distributing things. Let's say you wanted to distribute some things like 2x into x squared plus 4. All right, this kind of goes back to the way we started the video, but it is worth seeing because in the next video, we're going to talk a lot about things that look like this, except in kind of a backwards way. So let's just practice some distributing of some different examples. So if I take 2x times x squared, well, this you can think of this as a 1 here. This is 1x, and you're multiplying it times 2 of them already. So how many x's do I have total? I have 3 of them. This is 2x cubed, and then I have 2x times 4. That's going to give me 8x. So you can distribute things that have x's and x squareds and things like that. That shouldn't be a problem. Let's do another one. Let's do negative 2x squared times x minus, let's say 5. All right, if you want to pause it and give it a shot, do so, and then come back and we'll do it together. All right, negative 2x squared times x. There's no number here, it's just 1, so you can think of it as just bringing the number along. That's not going to change at all. And then, as in the previous problem, x squared times x is going to give you, well, there's 3 of them total, so it's x cubed. And now I have negative 2 times negative 5. That is a positive 10, and that x squared comes along for the ride. All right. Before we finish this video up, I want to show you a couple more. I think this kind of as a bonus round. What if you had something like, say, this? Okay. So in this case, I don't have 2 things times 3 things. How would I handle something like this? This is why I say that I don't usually like to use the term FOIL. Again, there's nothing wrong with it, but FOIL only works for things that are 2 pieces and 2 pieces. But I have 2 pieces and 3 pieces, and so that whole kind of concept breaks down. But if you think about this as distributing, there's no reason why there's only has to be 2 pieces here, right? Why can't there be more than that? The concept is the same. So what I'm going to do is I'm just going to distribute this first piece, this x, to not only that one and that one, but also the third one. I'm just going to distribute it to all 3 of them. Let's do that. So x times x squared gives me x cubed. X times 4x gives me 4x squared. And then x times 5 gives me 5x. It's the same exact thing as it was before. It's just now that I have a third term over here, I have a third multiplication. All right, let's do distributing this second piece, the second term here. That's 2 times x squared gives me 2x squared. 2 times 4x gives me 8x. And then 2 times 5 gives me 10. Now, the only thing that you have to be really careful with this, or at least I find most of the time where you're going to make mistakes is combining these together. You got to be very careful. Let's see what we can do with that. The x cubed term, there's only one x cubed in this whole thing, and that's going to be the case every time, most likely. So I'm just going to write that down. Now this piece here, this is x squareds. How many x squareds do I have here? Well, I have 4 of them here, and I have 2 x squareds over here. So the total number of x squareds I have is 6. So I have 6 x squareds. And I know some people like to cross these out. That's probably not a bad idea, just to kind of keep up with what you've done so far. And now we're going to look at this piece. I have 5 x's, and I have another 8 x's. So how many x's do I have total? That's 13 x's. Cross those out, and then I've got my lonely 10 just hanging out by himself. Okay, I could probably do this for another hour, and show you all kinds of other variations. There's lots and lots of other examples and variations you could do, but this is a good starting point. It's definitely going to be more than enough for what we're going to use this for. And the next video, we're going to talk about how to take this process of multiplying things like this backwards. So the idea is, what if you're given something that looks like this? Or more specifically, something that looks like this, and go backwards and get its pieces. A little bit more thought involved in that one, but I think it's really fun. It's kind of like working a puzzle. All right, so that's going to do it for this video. Thanks for sticking with me to the end, and I hope to see you guys in the next one.